Welcome to 5th grade math with Miss Howard. This lesson is looking at how do we multiply fractions to find the area of something. So what is area? When you're looking at this picture, you should think, okay, area. I've heard this before. I learned about this in 3rd grade and 4th grade. When I think of area, I always think of the inside of something, almost like a big area rug that you might have in your house. And if you remember back to 3rd and 4th grade, you talk about area, you're talking about how many blocks are inside of something. So if we look here, and one strategy to find area is just to count. We could count our blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But we are in 5th grade and we can count, but we know better strategies than that. I want you to think for a minute. We have been using this area thing that I'm thinking about in my brain all year. Some of you might have called it the box method. Nope, not. Oh, you are so right. The area model. And when we use the area model to multiply, that's what we're doing. We're finding the area of something. So we know that when we find the area, that's the same thing as saying length times width equals area. So we can multiply length times width and you will get area. And area is always written as squared. So for this problem, 5 times 3 equals 15 centimeters square. Now I want you to take a moment and just look at this model. What do you notice? What do you see? What do you need to figure out before you can find the area? So I'm going to write up here. Remember, area equals length times width. And our question says, what is the area of this shaded rectangle? And we see it shaded as a nice little purple. So it's not talking about the whole thing. It's just talking about that shaded rectangle. Now, let's look here. We know this whole thing right here is 1 unit. So if this is 1 unit, what is this going to be right here? This whole thing right here is 1 unit. 1 unit. So what's one of these pieces going to represent? I hope you said 1/3, because there are 3 pieces and one of them is shaded. So we know one of these pieces is 1/3. Let's go look over here and do the same thing. If one of these whole things is 1 unit and there are 3 equal pieces, what are each of these going to represent? This is going to be 1/3 and this is going to be 1/3. So we end up over here with 2/3. So that's my length. What's my width? Is 1/3. So now we have 2/3 times 1/3. Remember, we're just looking at our shaded piece. 2/3 times 1/3 equals 3 times 3. Oh, 3 times 3 is not 3. 3 times 3 is 9. And 2 times 1 is 2. So 2/9 units squared. Remember, that's very important to have our units, and sometimes I might say feet, inches, centimeters, meters, all those good things. But in this case, it's just talking about units. So our answer is 2/9 units squared. Let's look at another one. So same question. What is the area of the shaded rectangle? So we are looking at the orange part that's shaded in of this rectangle. Before we can do that, we have to figure out what each of these little pieces are worth. So if this right here is 1 unit all the way across, how many equal pieces is it split into? 1, 2, 3, 4, 5. So one of these pieces is 1/5. 1/5, 1/5, 1/5. So on this side, how many fifths do we have? If you count them all up, we have 4 fifths. 4 fifths. We write that a little neater. It's a little sloppy. We have 4 fifths. Now we also know we're finding area, so that's telling us we need to multiply our length times width. Now let's look over here. For this unit over here, I have one unit that's split in two. 1, 2, 3, 4, 5 pieces, 5 equal pieces. So each of these are 1/5. Now how many 1/5s do we have this way? We have 1, 2, 3 times 3/5. Now we're going to multiply these together to figure out our area. 5 times 5 is 25. 4 times 3 is 12. Let's think. Are there any numbers that 12 and 25? Let's think of our factors of 12. 1 and 12. 2 and 6. 3 and 4. Nope. That's my simplest form. 12 and 25 units squared. And the reason why we square this is because there are two sides. Squared. Squared. There's a length times a width. And this is a 2D object. Here's another one. I want you to try this one on your own. So go ahead and push the pause button and don't push play until you have an answer or if you're really stuck. Okay, go ahead and push pause. Okay, welcome back. So our question says, what is the area of the shaded rectangle? Let's first look at our side. This is one unit. There are how many pieces? 1, 2, 3, 4, 5, 6. So this whole right here is split into 6 pieces. So each of these is 1/6. 1/6, 1/6, 1/6, 1/6. And this, even this white one would be 1/6, but we're only looking at the purple. So if we look at the purple, we have 1/6, 2/6, 3/6, 4/6, 5/6. So we have 5/6. We're finding the area, so we're multiplying. And let's look over here. Let's check just to be sure. How many equal pieces do I have? I have 6. So 1/6, 1/6, 1/6, and so on and so forth. But how many of those 1/6 do I have? I have 3 of them. So 1/6 plus 1/6 plus 1/6 is 3/6. Now let's multiply. 6 times 6 is 36. 5 times 3 is 15. Let's think. 15. What are factors of 15? We have 1 and 15. We have 3 and 5. Ooh, I can simplify this. 15 divided by 3 is 5. 36 divided by 3 is 13. So I was able to simplify this one. So remember, if you can simplify, I want you to check and see, can I simplify? So my answer is 5/13 units squared. If you got to this part right here, 1536, great job. But also remember, we always want to write our answer in simplest terms, or it's also called simplest form. I thought I'd mix it up a little bit and I added a little word problem in here for us. It says a swimming pool measures, and I like to draw myself a little swimming pool, and I see that my sides are not all the same, so it's not a square, it's kind of a rectangle, but it doesn't have to be perfect. It's just my mathematical model to help me. Can't have that little opening, all the water will roll out. So I know that one side is 16 1/3 of a foot, and I know that one is 8 1/2 of a foot. My question is, what is the area of the swimming pool? I like to have my picture. There's Miss Howard swimming in the swimming pool. Yeah, that's why I'm not an art teacher. Okay, let's continue. What is the area? We know that area is length times width. So, length times width, 16 1/3 times 8 1/2. Now, here's a question I want you to think about. Can I just multiply and say 16 times 8, write down what I get, 1/3 times 1/2, write down what I get. I want you to think about it. I want you to try it and see what you get. Go ahead and pause it and try and see what you get. Now I'm going to explain to you why we cannot just say, oh, 6 times 8 is this. That's my whole number. Or excuse me, 16 times 8, and write that down as my whole number. And 1/3 times 1/2. The reason why I cannot say that is because I must multiply 16 times 8, but I also must multiply 16 times 1/2. Then I must multiply 8 times 1/3, but I also have to multiply 8 times our whole number of 16. So it's almost like you're leaving out half of your problem. So let's go ahead and start to solve this. We know we first have to change each of those to an improper fraction. 16 times 3, let's see, 16 times 3, 6 times 3 is 18, 48. So 48 plus 1 is 49/3, times 8 times 2 is 16, plus 1 more is 17. So now I need to multiply. I know my denominator is going to be 6. Now, I do not know in my head 49 times 17. I just don't. So I'm going to go over to the side. There's nothing wrong with that, but I know strategies to solve it. 49 times 17. 7 times 9 is 63. 7 times 4 is 28. 29, 30, 31, 32, 33, 34. For my goose egg. 9, 4. What's that at? 3, 13, 8. 833 sixes. Oh, that's a lot of sixes. Now, I have to divide. This is my division sign. This is an improper fraction. 833 divided by 6. 6 goes into 8 one time. 2, bring down your 3. 6 goes into 23, not 4 times, that's 24, 3 times. It's 18. Equals 5. Bring down your 3. 6 goes into 53. Let's see. 6 times 9 is 54. So 6 times 8, 48. So my answer is, oh, there's a lot going on. I'm going to erase something somewhere. Here, we'll erase my work down here. Let's see. Okay, we'll erase this down here. And my final answer, the area equals 138 and 5/6 feet squared. That is my final answer. Now, with a problem like this, I would definitely go back to each of my steps and make sure I multiply correctly, because there is a lot of room for error. So think of the strategies we talk about when we are multiplying, dividing, how we can use the inverse to check, and all of those good things. Great job.